Good evening, everyone. This is the last installment of the exam number 2 review. I'm going to be finishing up the multiple choice questions as we proceed in this video. I'm not going to do the short answer questions. I'm just going to do the multiple choice. Okay, so question number 14 reads, in the protein purification process, we described using a salt to precipitate proteins. Which salt did we use or describe using? This is a process known as salting out, and the salt that we used was NH4 SO4. This takes you back to Gen Chem 1. This is ammonium, and this is sulfate. So the correct answer is ammonium sulfate. So answer option A. People have a tendency to write ammonia sulfate or something of that nature, but this is just kind of a discrete question. You have to know this information, or this is something that's done in practice, and this is the salt that's generally used. Okay, so A. Question number 15. Which of the following is commonly known to be a gel run under denaturing conditions? Okay, so whenever we're denaturing, we're taking a folded protein and we are adding something to basically linearize it. And so what are we adding? We're adding a couple of different things. One thing is we're adding beta-mercaptoethanol. We could also be adding DTT, dithiothiotol. Another denaturing agent that's commonly used is urea. And basically what we're doing is we're trying to disrupt any sort of interactions between the side chains, so those R groups. And one thing that we're going to be doing is we're also going to be providing our protein with a uniform negative charge, and we do that by the addition of SDS, sodium dodecyl sulfate. SDS. Okay, so for this sort of question, we want to look at that and say, well, what has SDS? And the good thing is that we've got a couple different answer options, and only one of them has SDS in the name. So SDS page. It's important to recognize the names for the other separation techniques. For instance, native page, that's a non-denaturing gel. Isoelectric point or isoelectric focusing, that's a type of gel that we previously talked about in 2D gel electrophoresis. But that basically is the explanation for this one. You have to know sodium dodecyl sulfate is going to provide a uniform negative charge across a protein. Now, question number 16. Which of the following is a true statement? Okay, so this is a question that it wasn't really read as I want it to, and I guess my wording was just entirely too scrambled. And this was taking back to a protein, sorry, the hemoglobin tetramer. Okay, so I'm going to use a couple of different colors to display what that tetramer looks like. And that tetramer is an alpha subunit and a beta subunit. Those will come together to form a dimer, as is indicated here and here. And then what happens is these two different subunits come together, and what they form is a tetramer that looks a little bit like this. Now, what the question was getting at was basically what's the nature of this interaction between each unit and this interaction right here between those two dimers. And what I was getting at with this was kind of a discussion of pH. So this tetramer, if you change the pH, you will see this dissociation. And that is because hydrogen bonding is going to hold these together. Whereas these individual dimers, so I'm going to label them 1 and 2 here, if you change the pH, those are going to remain intact. And the reason for that is because they have hydrophobic interactions, stabilizing those. So basically, none of these are really good answer options, but that was kind of the message that I wanted to convey. So what that means is, and I'm going to post this as an announcement on Tracks, if this question was marked wrong for you, please email me along with a snapshot of your Scantron showing that it was marked incorrectly, so I can give you credit for this question. All right, question number 17 reads, which of the following peptides would be cut by chymotrypsin and elastase, but not trypsin. Okay, so chymotrypsin and elastase. So what we are looking for is something that's going to cut after hydrophobic residue like phenylalanine, tyrosine, or tryptophan. I'm sorry, a bulky aromatic residue, and elastase is going to cut after a small residue. Okay, so then trypsin, however, it's not going to cut after trypsin, and trypsin cuts after positively charged residues. So when we look at this, looking at our different answer options, looking at answer option A, would that be cut by trypsin? Yes, it would, because that lysine at the very end termini would be something that trypsin would go after, so that one's out. Okay, answer option B, that has a lysine dead center of it. Would trypsin cut that? Absolutely it would. Answer option C, AKRRD. Okay, what we have there is a lysine, an arginine, and an arginine. Those are 3 positively charged residues right in a row, so trypsin would cut all of those. Just by process of elimination, looking at where trypsin cuts, we've narrowed it down to FALFK, so answer option D. Notice there is a lysine at the end of this, but that's at the C termini, and so there's no peptide bond for trypsin to actually digest there. Alright, so D is the correct answer. Okay, now, question number 18. A Ramachandran plot is helpful to determine which parts of the polypeptide chain are most hydrophobic, which parts of the polypeptide chain are most likely to have ionic interactions, which bond angles are favorable for phi and psi angles, and D, which bond angles are favorable for alpha and that's supposed to say beta angles. Well, this is again kind of a discrete question. You just have to know what a Ramachandran plot is. A Ramachandran plot is the plot that looks like this. It's broken down into a total of 4 quadrants. And what you see is 180, 0, negative 180, negative 180, 0, and positive 180. So what we're looking at, and when you look at a Ramachandran plot, you'll see regions that are kind of shaded, and what that shows are favorable angles. So the correct answer for this is which bond angles are favorable for phi and psi angles. So your phi and psi angles, whenever you think about N, C, C, N, C, C, well, this right here is going to be a phi angle, and this right here is going to be your psi angle, and these will more or less repeat over and over again. Phi, psi. Okay, I hope that was helpful. Question number 19. When sequencing a protein, which answer option below lists the first 3 steps in the correct order? Okay, so what we're trying to do here is we need to figure out the sequence of a given protein from the N termini to the C termini. So what do we need to do? Okay, answer option A, separate the subunits, break disulfide bonds, amino acid composition. B, separate subunits, amino acid composition, break disulfide bonds. C, break disulfide bonds, amino acid composition, separate subunits. D, separate subunits, N-group analysis, reconstruct the sequence. All of the above are incorrect. So the first thing that you need to do, and this doesn't apply to every protein because not every protein is going to have a quaternary structure, but the first thing that you need to do is you need to separate your individual subunits. Okay, so that brings us to answer options A, B, and D, because E, all the above are incorrect, is wrong, and C is also wrong. Now, after you've done this, so you have individual subunits, you need to break any sort of disulfide bonds. So when you break those disulfide bonds, now what you have are all the different polypeptide chains kind of in individual entities. So the final step in this is determining the amino acid composition. So what amino acids are actually in this polypeptide. And once you've done that, then you can go through and do your analysis with your molecular scissors and everything like that. But A is your answer for that question. Question number 20, what is the GroEL-ES complex? So the GroEL-ES complex has to do with protein folding and misfolding. And this is a large protein that is ATP dependent that helps refold proteins, or basically conclude the folding of proteins. So there were some other proteins that were discussed in this manner, in this context. So the chaperones, heat shock proteins, and everything like that. But ultimately what makes the GroEL GroES complex unique, or not necessarily unique, but significant, is that it is ATP dependent. So when you know that, you can cross out B. So it is an ATP dependent manner. Answer option C, a protein complex which isomerizes disulfide bonds. Answer option D, a protein complex which breaks disulfide bonds. So those answer options C and D are kind of off the table pretty quickly. Are there proteins that do those things, isomerize disulfide bonds? Absolutely. But the GroEL GroES complex does not do that. So our correct answer is A for this question. Okay, question number 21, our last of our multiple choice questions. Which protein is considered to be the T state of hemoglobin? So whenever you're asked about the T state of hemoglobin, or any protein for that matter, what you have to know is that the kind of functional state, or is that the non-functional state? And the answer to that is the T state. That's your tense form of the protein. That is the deoxy form of the protein. So there is no oxygen bound. That's an inactive form of hemoglobin. So that is the T state. The R state is your fully oxygenated hemoglobin. All right, well, I hope this was helpful. Again, good luck on the final exam. I hope you do very well. Thank you.